Hello, I haven't done a video in a while. I thought I was over making hot water heater controllers, but I don't know, the urge just keeps coming. This is my latest one. This is a single chip LM356, and it is super easy to build. I mean, if you can't build this, you should stop watching my channel. And here it is. I built it into a three-way DIN box, and what's unique about it is I have this 12-volt power supply, and this is rated at 1.5 amps. My little circuit here only takes about 10 milliamps, so it's well over designed, but it allows you to connect up to anything as long as it's over 40 volts, and it's a good, safe power supply that will not have problems with low voltage, causing the electronics to fail. I use only a single capacitor in here. It's a 470 microfarads, but it's a rather low ESR, and I just wanted to see what would happen with using probably the worst choice possible. And it works. I have a little switch here that I can switch between 6,000 microfarads, which is the capacitor bank inside my normal controller, and what's in this box. And I have jacks up in front. I mean, I have little controllers I'm making all the time. It's not hard, they're not difficult. This is a TL431 with a inverting FET driver chip. I use it not because I need a FET driver chip, but it has low voltage protection. It'll shut off if the voltage is too low, and it has hysteresis, and you always want hysteresis in a system. I use mostly time delays, but hysteresis provides stability. So anyway, it's just a couple resistors, and I was going to bring a flashlight down, but there's a tiny little FET. The DIN rail board here, I just put a little piece of metal underneath it, put a screw into it. It doesn't get hot, so it's not a problem. I have it's winter. I have a 500 watt array. It's it's not even 500 watts. It's 225 watt panels, so it's 450 watts, and I can get about 400 watts out of it if things are really ideal. It's overcast today, and I'm getting 80 watts here. This is kind of unique. I have a little switch here, and this is great for testing because in series with the solar panels, I can make a direct connection, which I have right now. I can flip the switch to the middle, and then I have 280 ohms in series. That'll drop it down to just 3 watts. And you can see I got this one little pulse. And it doesn't happen very often. I just switch the 6,000 out, and you can see that the frequency rate goes up, but it allows me to do testing. And I have a 6 ohm on the other end, which drops it down to about 50 watts. So it's nice. You don't have to wait for a cloudy day to do some testing. You just have to flip a switch, and you can get early morning conditions, heavy clouds, or you can do full power. Okay, I have a little shortwave radio here. It's at about 17 megahertz, and you know, switching power supplies are noisy, and if you listen, you can hear that little bit of a whine. Hope you can hear that. But if we go down here, I'm actually touching the positive supply. Right now, it's on the switched output. I mean, you put an antenna on a switched output and it's not making noise, that's quiet. And I have a little RC network here. It's not really needed, but you ought to throw it in. You can put a diode across the plus and the switched part, basically across the heating element to absorb any spikes that might come from inductance. But it's not really a big issue. I don't usually bother with it. And, you know, people say I'm doing things wrong, but it's very quiet. So let's switch back to and I have these these blue lines up here. That's a 2-volt separation. And so I can move this up, as you can see, between where it turns on and turns off is only 2 volts with 6,000 microfarads. Now if we go to just 470 microfarads, you can see it's much larger. The control system just works much better with a larger capacitance. You get lower ESR, less losses, and basically the heating element and the capacitor bank form an RC time constant. So the longer it is, the easier it is for the control electronics to control everything. Otherwise, you're dealing with looking at little spikes of ESR. I have normally a time delay, and what you're seeing when you switch to the other one is it takes time to turn on and turn off. And what it does is that increases the delta. But at 2 volts, and we're at 62 volts here, you're well under 5%. And it wasn't hard to achieve at all, and it's ultra stable. So I'll have the schematic in another one of these, but the nice thing about using this power supply is you can eliminate a pot. So there's a voltage adjustment right here, and the output of this is between about 10.5 and 13.5 volts. I set it in the middle. I set up the resistive divider so that it works in that range, and then you can do little adjustments right here. I don't really like that idea, but because little pots tend to wear out quickly. But initially, for someone doing this, it gets them going and it gives them confidence. You know, it's not how smart you are, it's how much confidence you have in what you're doing and your whole attitude towards it. I find any project is almost totally about personality, so give it a try. Oh, and the other thing I have is I'm doing just 3 wires here, but you can see all these extra wires attached here, and this yellow one powers this, and there's a little orange one which goes to the voltage divider right here. And if you see, we have a little red LED, and all you have to do to turn this off is to put a thermostat in between the input to this LED, so you'll have a visual indicator of when the thermostat is on. And the other thing is this drops the voltage about 1.7 volts. It's a red LED. And if you have a system that's, say, maybe 80, 90 volts, you can put one of these in series, and you can put a switch across it, and you can have like summer condition, winter condition. It'll vary the output voltage by 1.7 volts, so you can compensate for temperature conditions. And as simple as this is, for 50 cents, as long as you're willing to run 2 wires outside, you can add a temperature sensor, and this thing will auto-correct for temperature conditions. So it's really a nice system. LM358 You can buy 50 of them with sockets for $7. I mean, if you blow up number 40, maybe it's time to abandon the project, but hey, when I built this, I had problems. I blew up my first FET, and what I did was I was using a 100 ohm resistor in series as the FET gate drive. Well, I grabbed the wrong resistor, put it on the meter, and it said 100. I was happy because I was pretty sure that was one of the 100 ohm resistors that I had in stock. It turned out it was 100K. So the FET got really hot and burned out. I make mistakes. It's easy to get the pin outs a little weird, you know. You get lost in things. It's all right to make mistakes. Just keep trying. You know, if you put something together and it works the first time, you have learned nothing. And I don't really care if you ever heat water. I want you to learn some electronics. So stay around for the next video.